an insane idea about quantum physics. Before I tell you this, I should tell you why I'm an expert in insane ideas. I am, after all, a psychiatrist. How I learned to be a psychiatrist is that from as far back as I can remember, my father was psychotically depressed, and he would be furious at my mother and sit silently at the dinner table and then storm off to the basement to his shop, and then my mother would send me down there to try to talk with him, calm him down, bring him back to civilization. It was quite the task. And from that experience, I came to love talking to crazy people. Subsequently, I spent 27 years as a doctor running an inpatient service for the most chronically mentally ill, the most impoverished psychotic people ever. The ones who were too paranoid to live in the homeless shelter. That was a Jeff Boyd kind of patient. And I would see these guys who were so depressed, and I'd think, I love this guy. Louis E. Little, my cousin, invented the insane idea which I'm about to present to you. Now, Louis is about the most brilliant person and the most argumentative person I ever met. He once had a long argument with me about why I would not bicker with him. I said, I don't see the point of it. But he didn't see the point of not bickering. Did I mention that Louis is brilliant? That's another reason I didn't want to argue with him. He would win every argument. He was smarter than me. Anyway, he studied quantum physics first at Brown and then at Princeton University, and he came to the idea that either they were crazy or he was crazy. A pretty interesting idea, I think. And he eventually came to the conclusion they are crazy. Ha! Which, of course, implies he's not. But then he had to come up with his own theory of, how do you solve this problem of the quantum world? For 30 years, while Louis worked in the stock market in trading commodities, he would spend weekends and nights studying quantum physics and experiments and theories and trying to come up with his own radically different approach that would explain all these things in a logical way, and eventually he did. He came up with the idea that if waves and particles go in opposite directions, if particles follow waves backwards, then suddenly the whole quantum world made sense and quantum weirdness went away, and I thought that was a pretty interesting theory. However, when he presented it to the physicists and the scientific community, they said, "You're crazy." How the quantum world really works. So I figure today I'll try to explain to you how the quantum world really works. And we're going to particularly focus on something called the double slit experiment. I built this model. Atoms or some kind of particle comes out of this gun. It goes through the two slits here and makes an interesting pattern on this screen, a wave pattern. And the question is, how does that happen? 3 basic ideas. Number 1. Particles follow waves backwards. If particles follow waves backwards, then you can make sense of the pattern on the target screen. Each point on the target screen emits 0 energy waves. The waves go through the 2 slits, and the one through the upper and the lower slit, they interfere over here at the electron gun, and based on the intensity of that interference, a particle is either fired or not fired to follow that exact wave back to the point from which that wave is coming. The final data will tell us where there is constructive versus destructive interference at the gun, at the particle gun. Let's consider elementary waves coming from point A in the middle of the target screen and B slightly below that. Point A on the target screen emits elementary rays that go through the 2 slits, and when they converge on the particle source, there is constructive interference. The peaks of the upper wave add to the peaks of the lower wave, and there's a great deal of amplitude and therefore a higher likelihood that that wave will trigger a particle to follow it backwards, and therefore a higher likelihood that a dot will appear at point A in the target screen in the final data set. The distance is greater from point B to the upper slit than to the lower slit, and therefore the waves are out of phase as they go through the 2 slits, and therefore as they converge on the gun there is destructive interference. The waves cancel each other out. The peaks of one fill in the valleys of the other, and there's flat water, and therefore there is no likelihood of a particle being triggered, and therefore in the final data set point B will remain black. Wave function collapse occurs when the particle is fired, not when it hits the target screen. Everywhere in nature there are elementary waves traveling in all directions at all wavelengths at the speed of light, carrying no energy. That is the half of nature that science chooses to ignore. The second thing I need to tell you about is why it is that we can't know and don't know which slit a particle came through. We have to put a detector inside the double slit experiment. See the eyeball? That's supposed to be a detector. Now this detector, in order to see something, it's not just looking, it has to be emitting a small amount of energy, ever so small. But the fact is that these waves, these elementary waves, convey zero energy. What happens when a zero energy elementary wave intersects the energy radiating out from the eyeball? Something unusual happens. There's a change in the character of the elementary wave. It loses its ability to interact with the other elementary wave, the one going through the lower slit. We symbolize that change by showing the upper ray turning from a red arrow to a blue arrow. Previously, there was interference of the waves impinging on the electron gun from the two slits, constructive or destructive interference. But now, things have changed, so the upper and lower wave no longer have any relationship to one another. There is no interference, just two independent waves impinging on the particle source. The target screen gives us a map of what is happening in proximity to the electron gun. As you can see, the pattern on the target screen now shows us no interference. Here's an analogy. Imagine a married couple that enjoy each other and interact harmoniously until the day when one of them has an affair and is seen naked by a detector. After that, the two people, or two waves, are estranged from one another. Each goes his or her own way without any interaction between them. Number 3, zero energy waves. Now, how on earth could a zero energy wave accomplish anything? After all, it has zero energy. I presented these ideas over and over and over again to the American Physical Society, and the experts, the leading scientists who I find intimidating, would tell me, zero energy waves? Ha! You must be insane! So I was thinking, well, yes, of course, we're all insane. But I didn't tell them that. In quantum mechanics, probability can flow like a flux or current and have a huge impact without any energy. The Schrödinger equation is an equation about probability waves, not energy waves. It appears, therefore, that elementary rays are the physical analog, the foundations in the physical real world of probability amplitudes. In another video, I explained the quantum eraser experiment. Now I will make everything crystal clear. Having figured all that out and being ready now to tell you these 3 things and make everything crystal clear, I've got a problem. I've run out of time. So, thanks for spending some time with me. I explained everything in another video called The Whole Story.
Greetings, I'm Louis Little. Jeff Boyd has done a marvelous job here of presenting the elementary wave explanation of the quantum eraser experiment, and I want to thank you for your interest.